optimization problem. We've gone through one that's almost exactly like this before. It's basically a good question because it doesn't really force us to do much calculation. It just makes us kind of try and understand everything. So here I'm already starting to draw this line right here, which is the hypotenuse of this right triangle. They give you that this is a rectangle. And they tell you something about this semicircle. They tell you that it has a radius of 20, which means that this length is 20. Now, that's a good thing to start off with. The area of this rectangle now is given by this formula in terms of x, where this length is x. Now, that means that this length is x as well, and the entire length is 2x. Now, in order to get the area, you should see that then, like I said, this length here is 2x, right? And now, if I want to get area, I need to know this length. And this length is given right here by this. But why is that true? That's true from Pythagorean theorem, right? If I don't know what this length is, I know this side squared plus this side squared equals this side squared. So I know x squared plus whatever question mark is squared has to equal 20 squared, which is 400. Now I solve for question mark by minusing the x squared and taking the square root of both sides, and you should see that question mark is just the square root of 400 minus x squared. Now, with that fact, you should see that then the area, this length is, right, this length is square root 400 minus x squared. And then the area is indeed, the area of this entire thing is this length times this length. This length is 2x times this gives me the area of this entire rectangle. Now, it tells you that the derivative is this function right here, and it gives you critical values. And then it can also be shown that a prime changes from positive to negative at 10 when x is equal to 10 root 2. So at 10 root 2, right, so here's your 10 root 2 on a number line. It goes from being positive, the derivative is positive, 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 and then it's 0 here because that's a critical value, negative, 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 negative. And basically what that indicates is that the original function, the area, is increasing, 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 and then it begins to decrease. So then that's some point. Now, they want you to find out which of the following statements is true. Well, what's true is that this is going to be a relative max. Okay, and with that, we could use that information to answer this question. So what do we have here? The inscribed rectangle maximum area has dimensions. Okay, careful. Now, this x value, right, that's not the width. The width is equal to 2 times whatever x is. And in this case, x is 10 root 2, so it's 20 root 2 is the width. And the length is given by this function in terms of x, so it's 400 minus 200, right? Because this squared, right, this x squared, when x is 10 root 2, is 100 times 2. It's 200. So it's square root 200. And that's the dimensions. The square root of 200, though, is the square root of 100 times 2, which is 10 root 2. Again, so the length is then 10 root 2. And the width is 20 root 2. So maximum area has dimensions 20 root 2 by 10 root 2, because that's width by length.